Hello and welcome to this lesson 6 of the straight line course. We're going to be looking today at the equation of a straight line. This will be mostly revision for you to go through how we get the equation of a straight line, what it looks like, and looking at another way of representing the straight line formula. And so it's got here, whether or not you did this last year with your National 5 teacher, it's got this statement of y minus b equals mx minus a. And I'm going to assume that I'm going to start from the point where you haven't done it. And that's what I'll do for the examples. You might have used different terminology, or you might have used only y equals mx plus c. That's fine as well, but I'm going to be using this formula in order to answer the questions. Also, it's got here a general formula of straight line, which I'm going to be rearranging all the answers rather than y equals something. I'm going to be rearranging them so it's in this form. And I'll talk about that whenever I get to the answers to the questions here. So let's look at this first. If you have a line which is horizontal, the gradient of that line is y equals whatever the y coordinate is, the y-intercept. And if you have a vertical line here, it is the only equation that doesn't have a y in it. It's x equals. So yeah, just so you're aware of that. Okay, let's look at these examples. Find the equation of the line with the gradient of a third passing through the point negative, or 3, negative 4. And so what we should do is, this is gradient m, and what we do is we call this the point A, and we call this the point B. The x coordinate being A, the y coordinate being B. And since we don't know the y-intercept, we can't just go into y equals mx plus c. We need to use y minus b equals x minus a. Y take away negative 4 equals a third x minus 3. That gives us y plus 4 equals a third x minus 3. Now it says here in the note, it's usually easier to multiply out the fraction before expanding the brackets. Now what that means is, rather than multiplying this bracket by a third, just trying to see if I can make myself some more room. Rather than multiplying out that bracket, we're going to multiply everything by 3. Now what that would do is it would get rid of this third here, that would cancel, and it would multiply these individual two terms by 3. So what that would look like is 3y plus 12 equals x minus 3. Then we want to rearrange it so it has got everything combined together, as in, I'm going to move it all so that the x is positive. So I'm going to move everything to this side of the equation, to the right, and then combine together the like terms. And so as long as the terms are collected together, these terms are collected together, you can actually leave it in any form. You can leave it as y equals. It doesn't matter. But this is the way I'm going to rearrange it here. So if we rearrange that, take away 12, take away 3y, we'd be left with x minus 3y minus 15 is equal to 0. So that would be the answer to the first question. Now you can also answer that question if you were taught the way of just using y equals mx plus c and then finding out what c is, then getting the equation from there. That's absolutely fine. You can leave your answer as that. That's not incorrect. Okay, this one here doesn't give you a gradient, and so the only difference here is we need to work out the gradient first. So it's m equals y2 minus y1 over x2 minus x1. So that's -1 over -5. So it's a fifth. So our gradient is a fifth. I'm going to call this A and this B. You could have called that A and that B. It doesn't actually matter. So it's y minus b equals m x minus a. Y minus 2 equals 1/5 x minus 3. Y minus, so we're going to multiply by 5. So 5y minus 10 equals x minus 3. And then rearrange it so that x is positive, so it becomes x minus 5y plus 7 equals 0. Okay, let's have a look at this third example. This third example, find the equation of the line passing through these. Now you should, before doing anything, realize that you've got the same x coordinate here. And if we did a little sketch here, -3/5, somewhere around here, 4, -3/5, 5. Well, that is a vertical line. And the vertical line has an equation of x equals, so every single coordinate has the same x coordinate. And so the equation of that line is x equals -3/5. Okay, next one. Looking at extracting the gradient, and so you should know that if you're given an equation, you can rearrange that in order to find out what the gradient is. And so this equation, we're going to rearrange it so that y is the subject. So we're going to take away 3x, take away 4. So it's 2y is equal to -3x minus 4. Divide both sides by 2. Y equals -3/2 x minus 2. So we're comparing it to y equals mx plus c. The gradient is then -3/2. Next one. Find the equation of the line through A, which is perpendicular. So remember from the last lesson, we did perpendicular to AB. So first of all, we should work out what the gradient of this is. And then there's a clever way of working this out. And because that's minus y here, if we just move that y over to the other side of the equation, that will become y, which is positive y. So the equation would turn into y equals 5x minus 18. So the gradient is 5. And if we want the line which is perpendicular to the AB, a line going from A to B, we know the gradient, a perpendicular gradient, is then -1/5. So we flip the fraction and we change it to negative. Now we've got the gradient, we have this point A, because it says it goes through that point A, and it has a gradient which is perpendicular to point B, or perpendicular to AB. And so we're going to use y minus b x minus a. So it's y take away -3 equals -1/5 x minus 3. That changes to plus 3, and then we're going to multiply it by 5, so it's 5y plus 15 equals, this negative is still important, minus x plus 3. We then want to rearrange it so the x is positive, so we're going to move everything to the left-hand side this time, so it's x plus 5y, take away 3, so that is plus 12, equals 0.